Hello, today I'm going to go ahead and demonstrate and show a few of the functions and layout of my new motherboard. It looks very similar to one I previously designed. Functionally it's the same, but the layout is different. So hopefully if you're going to be using this video for the older motherboard, you'll be able to make those adjustments, and I'll kind of point them out from time to time. One of the main ones, of course, is the power supply is no longer at the front of the board, it's at the back of the board, and the barrel plug comes off to the side. But everything else is functionally the same jumpers, and this one has a little more room in the layout to make things easier to access. So, looking at the board, you'll notice it has lots and lots of male header pins, which makes it really easy to hook things up, as well as a set of females. The way it works in general is all the male pins closest to where the chip would be socketed are going to be your signal pins. They go directly to the chip. Okay. All of the center row of pins here, all the center male pins, are going to be power supply pins. So when you plug in a three-pronged wire, like you typically find on a sensor or servo, you'll have the option of having it powered directly. So there's lots and lots of power supplies. The outermost pins, okay, the outermost male pins are going to be ground. These are all going to be hooked up to ground. Now, let's look at the jumpers. We have three different jumpers on this board as well as the older board. One jumper should be labeled VN and 5. Okay, in the case of this one, it's right here. If it's on the VN setting, that means whatever batteries you happen to have hooked up. Okay, in this case, I have a 7.2 volt pack. I'll show you in a moment. That means that this entire center row of pins is going to be at 7.2 volts. It's whatever the plug is, whatever you're supplying. If you're applying at 12 volts, it's going to be 12 volts. 7.2, it's going to be 7.2. Okay? So if it's on VN, that side, that makes it ideal for hooking up things like a servo if you want a lot of speed. Okay, it's going to be your maximum power output. With it on the 5 volt setting, what happens is it cuts off the direct link to the barrel plug, and it feeds it to a 5 volt 2 amp regulator, which means that all of these are going to be then 5 volts. Alright? On this side, there's also a jumper, in this case it's located here, that allows you to select between 3.3 and 5 volts. If it's on the 3.3 volt setting, it's going to be getting all of its power from an onboard voltage regulator on the teensy. On the older versions, that would be 100 milliamps. On the 3.2, that's 200 milliamps. So if you have it on a 3.3 volt, then all of these pins are going to be supplied with 3.3 volts. This side is unaffected. It's going to be chosen by the 5 volt VN jumper. If you have it on a 5 volt, it's going to then have its power supply come from the 5 volt regulated side. If it's hooked up to USB, the same rules apply. If it's hooked to the USB cable and this power switch is off, and I'll explain that in a second, that means it's either going to be getting a 5 volts from your USB cable, or it's going to be going through an onboard voltage regulator and running 3.3 volts. Ground. This side, all the grounds go directly to system ground. Okay, they all tie into the ground of the, either right into the ground here on the barrel plug, or it ties, well, which is tied into the ground on the teensy chip, and that's it. It's a straight ground. There is an option on the teensy. Okay, there is something called analog ground, and if you set the analog, there's a jumper that says both ground and A ground for analog ground. If you set it on the analog ground, you're going to have a bit of a buffering isolation, and you're going to get a smoother reading from your analog sensors. Okay, I tend to leave it, in my experimentation, the differences have been subtle. I tend to leave it on system ground. But I imagine if you're shocking it with large loads of motors or something like that, you may want to isolate it, or precision of measurement is really important. you may want to have it on the analog ground setting. I'm going to insert a chip and then explain the switches. So the way the chips go in is they go in directly this way with the USB facing the switches. They are a firm fit. They do not go all the way down flush. The pins are longer than the socket. You will have a gap of perhaps 3 or 4 millimeters between the chip and the surface of the socket. Okay. When you see this, you'll see why the switches are kind of an important layout. So this switch turns on and off the processor. This switch turns on and off the power supply on this side of the board. It's very handy, that way you can turn off, for example, all the power going to your servo motors and whatever else, still do all your software testing and analyzing, and not have your robot moving around. So these two switches have two different functions. You'll notice that if I want to plug it, currently it is in the off state. If I want to plug in a USB cable, okay, it plugs in just fine. But when I do, the board goes live, and the USB is now powering supply to my chip, which also then makes all of these pins high at the value that I have it set, either at 5 volts or 3.3 volts. This side is still entirely dark. Okay, I'd have to turn on this switch. If I turn on this switch, nothing happens because I currently have it set for VN. I don't have a battery here. There is no VN. If I want to power this side with the USB, it'll only be powered without batteries on the 5 volt side. So now everything is getting 5 volts from the USB cable, and I can turn, you can see the green light, I can turn on and off this side, okay, with this switch. Now, this switch is totally inactivated. Okay, it won't work because the USB cable is blocking it. That's to keep you from inadvertently having batteries hooked up and supplying a battery voltage and a USB voltage to the system at the same time. It's physically blocked. You can't turn it on. If I unplug the USB cable, okay, and I have my batteries plugged in, now I can run it with the battery pack, okay, and it's running on battery voltage, but I can't program it at the same time. And you can see the entire system is working, okay. And then, of course, like I said, if you want to program it, you do have to turn it off, safely insulating your computer, and now you're back on USB power. I think that pretty much covers it. Oh, no, a couple more things. I'm sorry. Oddly, and I'll explain the justification for this because it is kind of interesting. These are your female direct links to the pins, so I can plug in, for example, straight copper wire and plug it right in if I want to do a breadboard experiment. Just 22 gauge wire, just solder it right in. Pin 13 and pin 12 do not have female equivalent sockets along this bus. They are located way down here. Okay, there's 12 and there's 13. Reason being, quite honestly, is because these are sold in bulk in even numbers. Odd numbers are very pricey and expensive, and not really justifiable. So to make the manufacturing costs stay reasonable enough, even numbered sockets are purchased, and the remaining 2 odd ones are placed down here. All right, so those are your females. There is also a male and female, I'm sorry, a power and ground available. All right, depending on this board or the older board, the important thing to remember is that the ground is always the furthest out. Okay, so if the socket is here or the socket is here, it doesn't matter. The ground is the one furthest away from the board. The power is the one that's closest to the board. So in this particular case, this one, a current setting of, what do I have it set at? 5 volts. At my current setting of 5 volts, that's going to be 5 volts. That is going to be ground. This is going to be 5 volts. this is going to be ground. I think that pretty much covers the motherboard, and I will see you again soon.